This is a continuation of homework set 39. We're going to look at questions 11, 12, and 13. Question 11. Suppose that the population of a city is given by this. Oh, it's exponential. Now, I'll rewrite it here. It is P, the population at time t, is equal to 100,000, e to the point 0.5t, where here's what everything is. T, this is the number of years from present. So from right now, T is the number of years. Okay, so T is the number of years from now. How large is the population now? Well, what is T right now? Remember what T is? T is the number of years from now. So at now, that implies that T is equal to 0. So what is the population at time 0, right when you start? Well, it's 100,000 times e to the point 0.5 times 0, all right? But 0.5 times 0 is 0, right? So that's just 0. So now you get the population now is equal to 100,000, e to the 0, but e to the 0 is a 1, right? So P of 0 is 100,000 times 1. So the population now is 100,000. Now, we went through every step here. You don't really need to do that. If T is 0, most of this is just going to go out, right? All of that becomes 1. All right, so that multiplier out here, that is the initial value. That's your start value. So in exponential equations, like the exponential equations, that multiplier out here is your initial value. That's your start value. Question 12. Here's what we know. That the number of airline passengers way back in 1990, all right, so back in 1990, the number of airline passengers was 466 million. Now, the number of passengers traveling by air has increased exponentially. Okay, now, as soon as it says increasing exponentially, here's what I'm thinking, right? You have some start value, which is 466, and then as time goes by, we get that exponential curve. So as more time goes by, there's exponentially more passengers, not just a few more, but a lot more. So as soon as I see this, airplane has increased exponentially, I'm thinking this, and I know the start value. It started at 466, so we start right here. All right, so what else do we know here? Now, it's increased exponentially according to this model. Let me write that down. P of t is equal to 466 times 1.035 to the t. All right, so this is exponential. You see it? It's exponential. The variable's in the exponent. And you see that multiplier out here? That's our start value. And sure enough, back in 1990, we started with 466. And they are telling us here that what is t? All right, t is the number of years since 1990. So everything starts in 1990. So that's our start value. So as time goes on, here's my picture over here. Here's my picture. As time goes on, what happens to the, say, population of airline travelers? It increases exponentially. But what do we want to know? Read the question. Where is it? Okay, here it is. In what year, all right, in what year, find T, what year? That's the time. In what year is it predicted that 900 million passengers will travel? All right, so here's what I'm trying to do. I'm going to write down what I'm trying to do. I'm trying to find T when P is equal to 900. Okay, so let's put that in. 900 is equal to 466 times 1.035 to the t. Now, let's isolate. Here's the exponential. This number is raised to the t, not the 466. So let's isolate this by dividing by that 466. So let's divide. We'll get 900 divided by 466. That is equal to 1.035 to the t. Now, it's exponential. Let's convert it to a logarithm. Now that base, I can use a base 10 or base e. I think I'll just use base 10, so I'll do it up here. So take the log base 10 of both sides. I'll get the log of 900 over 466. Let me write it so I can read it. That's equal to, now what do you get here? We know what this is. when you take the log of an exponential, the exponent comes down in front as a multiplier. That's why we do it, right? So it comes down as a multiplier. So I'm just going to do it. So I get t times the log of 1.035. All right, here's what's happening. You get the log of 1.035 to the t, but then the t comes down in front as a multiplier using our properties of logarithms, okay? Now, I want t. This is being multiplied by this number. So let's just divide by that number. So we'll get the log of 900 divided by 466 divided by the log of 1.035. That's equal to t. I'm going to put it in my calculator like this. Press the log key. I'll get the log parentheses. Type in 900 divided by 466. Close. Divide that by log of parentheses. You get 1.035. Close. Okay, that should be it. All right, so I got t is equal to about 19.133, so about 19 years. But what is t? All right, t, remember, it's a word problem, so go back and look what t is. T, all right, there's t. T is the number of years since 1990. So we start at 1990, and then we add 19 years, all right? So where does that put us? That puts us at about 2009. Question 13 tells us that a can of Coca-Cola back in 1960 was 10 cents. So way back in 1960 was 10 cents a can. Now this function here models the cost where t is the number of years since 1960. All right, so I'm going to write this function. So the cost depends on time. That's how to read that. Not just a bunch of symbols. There's actually meaning attached to it, translated. Cost depends on the amount of time that has gone by, and it's equal to this. It is 0.10, right, 10 cents, e to the 0.0576 t. All right, so it's exponential. T is the number of years since 1960. Now they're asking us, in what year is it expected that a can of Coca-Cola will cost $1? All right, so what I want now is the cost is going to be $1, and I want to find t. So what I'm looking for is this. Find t when c equals $1. You know, that doesn't look like a good c. Let me try to write that again. When c equals $1. So let's put $1 in for c. So we'll get $1.01 is equal to 0.10 e to the 0.5705. Let me get that right. 0576 t. Now, this is exponential, right? The variable's in the exponent. So we're going to isolate that by dividing. So I'll get 1.00 divided by 0.10. That's equal to e to the 0.0576. Now, if you like, you can go ahead and divide that, but I'll just have the calculator do it at the end. It's exponential. I'm going to use logarithms, and the base is e, so I'm going to use natural logarithms. So what I'm going to do here is I'm going to take the natural log of both sides. So on the left, it'll look like this. The natural log of 1.00 divided by 0.10, that's equal to, now, when I take the natural log of this side, I get the natural log of e to some power. The natural log of e, the natural log and the e are inverses of each other. So the natural log undoes the e. So you just get the exponent. So I get 0.0576 t. I forgot the t up here. And now I can solve this for t just by making that division. So I'll do it up here. T is equal to this fraction. I'm going to divide by 0.0576. And I'm dividing this, the natural log of 1.00 over 0.10. So I'll put it in the calculator like this. I'll have to press LN, so press the LN key. You get a parentheses. Well, actually what you get is LN parentheses 1.035 0.00 divided by 0.10, close, divide that by 0.0576. Now here's what I got. I got t equaling 39.975. You know, t is about 40. But what is t? So that 40 is not our answer. What is t? Back up here, it says this. T is the number of years since 1960. So we're 40 years since 1960. So if I take 1960 and add 40 years, I get the year 2000. All right, so back in 1960, a can of Coke was 10 cents, and then in 2000, it cost $1. And that finishes up questions 11, 12, and 13 here in homework set 39.